Hi, good morning, everyone. Thank you for joining in. We will shortly start the session in a few minutes. Just wait for a few more people to join in. And I'm going to send a reminder as well. All right. Good morning, everyone. Thank you once again for joining in and spending your last 3 days, couple of hours with us to study about the video fundamentals and some part of networking fundamentals as well. And if anyone is still looking to join by Microsoft Teams, you can use the same link as yesterday. I will post the link once again in the chat window. Okay. So since day one, we have talked about vendor checklist. We talked about imaging technology. We talked about the camera chipset. What is the construction of camera? The IP rating of camera. The WDR specifications for camera and uh, highlight, low light. We talked about thermal cameras. We talked about the IR range of cameras as well. Just a second. Just a second, please. Apologies, that was an emergency call. All right. So then we also focused on one key topic used for design in day one. That was identification, recognition, you know, uh, door is standard, identification, recognition, observation, and strong identification detection, all that. We talked about pixel per meter, we talked about the body percentage, 120%, 50%, we talked about it. Next, we touched on the basics of networking. In a CCTV, you have monitors, you have recorders. All of them are asking for data from the camera. So how much of data is being transmitted? Okay. The second day we covered uh, the some part of day one was covered on day two. So we talked about H.264, H.265, what is codec, coding and decoding, and what are the additional compression technology. We talked about Wisestream and other technologies on top of H.264 or H.265 to compress the video further. When the scene is idle, it will reduce the bandwidth even further. We even saw a live demonstration. Then we talked about how the vendors are categorizing their cameras. Then it's not purely based on resolution, it is based on the CPU that is used and how much of function you can achieve. Resolution is no longer a differentiator. Then we saw shutter speed, image quality, image gain, noise. If you increase gain, you get noise. You need noise reduction. If you increase noise reduction, there is ghosting. So we talked about also shutter speed. If you increase the shutter speed, you can capture fast moving object and so on. Then we talked about the fine balance, how you have to adjust each setting to get the right image quality. Then we saw network. We saw an example of Emma Smith and Chris Smith and so on. Family name, network and host ID. What is an IP address? What is subnet mask? What is gateway? Or the communication that goes outside the network is through the gateway. Then we talked about LAN, WAN. What is VPN? We saw basic IP tools, IP config and ping. Ping is to check camera online, offline. IP config gives you the spec IP address of your system. Then we also discussed on analytics. There are two types roughly: artificial intelligence and traditional analytics. Under artificial intelligence, the most accurate advanced is the deep learning, not the traditional machine learning. Okay, but both fall under the umbrella of artificial intelligence. But deep learning is the real real use for CCTV. Okay, using artificial intelligence, because a camera is training by itself based on the images that is shown. So we show thousands of pictures of a certain object, the camera will learn it and become trained automatically. So that is artificial intelligence deep learning, and it's very accurate. So even if a person is crawling or hiding, only half the person is visible, it will still pick it up as a object. And doesn't benefits of AI is not affected by rain, not affected by lighting changes in the scene. Whereas a traditional analytics, if there is rain, it will cause motion. If there is light changes, it will cause motion detection and so on. We saw ONWIF, we saw native integration, we touched on the basics of cybersecurity, and today we will continue with the rest. What is network recording? What is VMS recording? What is VMS solution? Some more tools. Then we will see how to design your control room setup and some more networking part also. Okay, so let's begin today's session. And some of the queries I have replied by email. And if you still have any questions, please let me know. Is my audio clear? Is anyone having audio issue? Okay, okay, great, thanks. Yeah, I got confirmation, it is fine. All right. I want to add one more point on the cybersecurity is why would someone even hack a CCTV system? The thing is, it's opportunity, right? If the hacker is before he was doing for fun, nowadays it's all about money, right? They hack the system, they ask for a ransom, you know, they ask you money and then they take money and then they release your system. So nobody hears about it, but it's all happening in the background because if a university system got hacked, they don't want the whole world to know that, oh, we got hacked. Yeah, I mean, it will be registered that, yeah, this particular system was hacked. They have to notify, but it doesn't come. I mean, documents don't get leaked online because they will pay the ransom and get their system back. So the hackers nowadays are finding opportunities to make money using this. So, and since we have an encrypted way of money transfer, so this has become very common nowadays. So if ever you want to find out some more information about it, there are websites just tracking all the cybersecurity issues globally. If you go to cybersecurity news, you will see day to day how many systems are actually getting exposed and how much they paid to get their system back. Okay, but ideally it is not recommended to pay someone. It is they might just come back again and ask you for more money. So, however, we are with our cybersecurity steps and measures, we are trying to make it difficult for the hacker to get access. Okay, another key important factor is to keep your systems updated. Okay, on a yearly basis or half yearly basis, it is recommended to keep the systems updated. All right. All right. So, what is NVR versus what is VMS? Okay. Now, both of them are basically a video management system. Okay. One of them is small scale, the other one is large scale. Okay. What is a video management system? If you manage more than one camera, if you see a live view of more than one camera at a time in one interface, or if you are recording multiple cameras in a central database, all this comes under the video management category. Let me give you a short demonstration. Video WDO device manager. So what I have here is basically a NVR, network video recorder. What is NVR? Network video recorder, where you can record IP cameras. Okay, when you have just one camera, you can easily go to the web page of the camera and manage the video. You can look at the video, you can record on SD card or on your PC. It's okay. But when you have multiple cameras, you want to have a central system which will manage them, right? That is a VMS. Okay, so here is a small NVR or a recorder, which is a mini VMS where you can add up to 32 cameras. There are recorders where you can add up to 64 cameras. Then there are recorders where you can add up to 300 cameras, depending on the specification of the recording unit, the CPU, the RAM, the operating system that is on the recorder. Based on that, the also the network card and other things, and RAID controller, storage controller. Based on the specification, you can the vendor will tell you how many cameras you can record in each server or recorder once again. So here I have an example of a basic NVR with 32 cameras which you can add. Okay, what is the benefit when you log into the web page of the NVR? You have the option to add cameras. You will discover the cameras in your network. It will automatically discover all of the devices. You will select the ones you want to add, and then you will add it to the right, apply, and that's it. All these cameras have now been added. Then they're all recording. In the NVR, you will find uh, I have here, you can insert a lot of hard disk. This particular unit supports 8 hard disks. There are NVRs with 16 and 24 hard disk. So all these cameras will be recording in the hard disk. Okay. So HDD map, this particular model has 8 hard disk, but I inserted only one. So all the cameras are recording in that first hard disk. Okay. Then you can create a RAID. We will see what is RAID later on. Basically you record on the NVR. Then you can customize how it will record, when it will record. Sunday nobody is there, so only record if there is any activity. The rest of the days from morning 8 to certain time, record continuously. You can customize this for each camera by camera by or NVR by NVR. You can customize this, so you are managing the recording. Then you have option to do user. What is user? Yeah, what is user? User means who has access to which camera, who has access to view certain or playback or do export. So you have option also to export the video. You can say I want to export from so and so time to so and so time. I want to export the video. You can see the live view of the cameras together. Um, you can also play back the cameras, check the timeline, go back and play the camera. So you can do these kind of functionalities. So here you can check, okay, what happened on certain date, who was there, and all that. Now, now coming back to this, not only this, analytics. Yeah, one of them asked you about analytics. If your camera has got analytics, you can search for the analytics in the camera. If there is motion or AI analytics, everything. So if you go back here, event rule, you can see the NVR also supports. You can set up analytics such as, okay, intelligent video analytics. You can set up tamper detection. You can set up motion detection, mask detection, AI camera. So if you have AI camera, you can search for the person by gender, male, what is his color of dress that he's wearing. You can do the same. So if your camera has got analytics, you can receive it on the NVR and search. You can also do normal search of events and so on. Okay, AI search. You can search for vehicle, what type of vehicle you're looking for. I'm looking for bus. Show me all the bus with the yellow color, and it will show all the incidents of yellow color bus. So NVR can also do event setup. So if there is an event, you can create a rule and say if ever the camera detected motion in any of the camera, apply. I want a pop-up. I want the camera to record. I want to send an email. I want to upload the photos somewhere. Uh, or or you can say I want to create a rule. If a camera detected motion and it detected tampering, if these two events occurred within a period of 3 seconds, I want to take an action, send email, and so on. So all these events, rules you can create. NVR or recording units, they also have built-in alarm input. Every camera has got built-in alarm input. You can receive that. So there are two types of alarm: hard wire alarm, software alarm. Okay, so let me write it here. Hard wire alarm, which means you will take a relay contact from, let's say, a fire alarm device or a door alarm device and connect to the camera, physical wire. Then of course software, that means our camera will be integrated by software to the access control. So whenever there is some door forced open, the camera or the NVR will receive the alarm and send the event. So that is without physical wiring. So that is software based alarm. So analytics also comes under software alarm, right? No one is connecting a wire for analytics. It's software alarm. So all of this the NVR can receive. Okay, you can also add Hanwha camera or third party camera. If you see here, you can it's already full, so let me delete some cameras. I can add on-wave camera also. It need not be Wisenet camera. I can add on-wave camera. Now it can be done. Now once I add all of this device, the good thing is I have option to manage the whole camera from one location, making it simple, right? Making it easy. I know where it is recording. I behind the NVR there is option to connect uh, monitor. Behind the NVR there are multiple network ports. I can do redundancy. One fail, the other one will take over, or I can have cameras from one network. I can have playback and monitoring the web page of the NVR from another network. I have double fan, double power supply. Optional, yeah. Not every NVR will have. So there are optional NVRs with all this. Now this is a recording unit. Now there are two types of recording units called embedded. Embedded means all the licenses, all the software, it's pre-installed. Okay. Second thing, the embedded can be um, can be Linux or Windows. Can be Linux or Windows. Okay. What is in Linux? You can have this management. Okay. See, our NVR is also Linux. We also have Windows based, but even though it is Linux or Linux, whatever, I can access from my Windows PC. I can go to the web page. It has a web interface, so I can completely access from Windows PC. There's no issues. Okay, some people prefer Linux, more stable, long-term use is good, and also it is much more cheaper compared to Windows-based servers. So Linux-based recording is available as well as Windows-based recording servers available. You buy from Dell, you buy from Promise, you buy from Infotrend, all these BCD, all these are suppliers for Windows-based recording servers. Okay, from most of them will come from Dell or HP at the end of the day. All right, so they will supply this servers with Windows. You can install the recording software on it. Okay, and you can record the camera. Now, what is the benefit? Windows based today is somewhat stable, similar to Linux, not better than Linux, um, but it's flexible. That's the thing. Why customers today prefer Windows-based recording solution is it's flexible. In the sense, when it is Linux-based, you will buy proprietary hardware. You'll buy from some vendor, and it will be pre-installed, right? Everything is pre-installed. Software, camera setup. Not cameras are not added, but all the functionalities are pre-installed. So you cannot uninstall it. You cannot change the hardware or reuse the hardware. After 2 or 3 years, you have to throw, or if you don't like it, you just have to throw it. You cannot reuse it. But if it is Windows, it's like your laptop. You can add some RAM, you can remove some, add some extra storage. You can remove that software, add remove programs, remove that software, and add some other software. So you have the flexibility. You don't like one video management software, uninstall, install something else. So that flexibility is there in Windows. Plus you have to pay for Windows license. Okay, that is another thing. So that's why Windows is slightly more expensive. And because Windows, there is no limit in terms of what kind of hardware you will use. Depending on your budget, you will buy Xeon processor. Some of you will buy i5 processor. Some of you will buy i7 processor. You can buy exactly based on your project. If your project has 10 camera, you don't have to go and buy a Xeon processor. You'll buy maybe i5 or i7, right? So depending on the specification required, depending on the number of cameras, you can customize your hardware and buy it. Okay, so that flexibility is there in Windows based recording solution. And the most important one is you have the option to simply reuse or repurpose. Okay. Then third thing is Windows based software are more easy to develop. So if there is a new feature, it's quicker to develop than on Linux. Linux takes a bit longer time. So few new features will probably come after 6 months, 8 months compared to Windows based software. So more development is done on Windows based. Okay. So that's the good thing, but the price of course is more. Now, if you have to design for your project a CCTV video management system, you have option. Okay. Linux or Windows. Now, Linux, you are not going to install Linux or anything. It will come pre-installed from the vendor. The hardware will look like this. I think I showed you some pictures. We can, yeah, they are already pre-installed hardware. You see NVR's recorders, they're already supplied by the vendor. You can buy from any vendor. They will have pre-configured hardware. It's called NVR, 64 channel, 32 channel, 100 channel NVR. Okay, you can buy from them. Okay, now if your project is small, go with these kind of solution. You don't have to worry what server to take, which windows to download. Should I update the windows? So is this RAM okay? Is this power supply okay? Did I install correctly? What Windows settings to do? All this headache, if you don't want, go for embedded solution. Plus you get price benefit. But the challenge is in an embedded solution, if you buy a 64 channel NVR, you cannot make 65. You have to buy one more device. Okay, it is pre-configured. They'll put a limit. This is what maximum you can add, and that's it. So it is pre-benchmarked. It will work 100% for 64 and 0% for 65. Okay, so it is already benchmarked for so and so channel. All the RAM, processor, whatever is used is configured for 64. You cannot add more. You can add less if you want, but you cannot add more. But in Windows, you can make some software updates. You can have some increasing the RAM. You can increase the capacity or reduce the capacity. You have that flexibility. Okay. So if your project is small, 200, 300 camera, buy 4 or 5 NVRs, done. And if your project is having distributed recording, I have recording in different branch offices, each branch only 40 camera, 50 camera, maybe total is 2000. It's okay. Just use the NVR concept. But when your project in one location, in one office or one hotel itself, you have 2000 or 1500 cameras, then buying an NVR can be more hassle and compared to buying a server, because Windows based recording servers, Windows based recording servers, they have higher camera channel capacity, 200 camera, 300 cameras. So if you are looking for uh, NVR versus Windows based servers, 64 channel, whereas this can be up to, let's say, 300 channel. So if you have a 1500 camera project, okay, so you will need how many? 1500 divided by yeah, 1500 divided by 64, 23 NVR, whereas 1500 divided by 300, I need only 5. So if you see, overall management becomes lesser. In order to manage 24 NVRs, you need like a lot of work. Also, it can be more expensive. Okay, so an NVR, let's say $3,000, 23 into $3,000, it's probably like 70,000. Whereas the server will be like 5 into $10,000, it will be like 50,000. So the NVR channel itself will become more expensive because the number of NVRs are higher. Okay, when the number of cameras are large, uh, trying to have more cameras per server is more beneficial. Okay, because it can reduce the cost. However, if this project has only 300 cameras, okay, then Okay, let's take 500 cameras. 64 divided by, sorry, 500 divided by 64. So it's like 8 into 3000, 24,000, whereas this will be 300 cameras by 300. So you probably have 20,000. Okay. Yeah. So, okay. Even in 500 cameras, okay, if you're reaching 500 cameras, in that case also, you can look at Windows, but the difference is quite small. Now, small projects, let's say 200, then of course this will be $10,000, whereas this can be 64, 200 divided by 64, maybe 4. Actually speaking, NVR cost is lesser than 3,000, let's say. So it's around 12,000. But okay, maybe my dollar price is not that accurate. Generally speaking, server-based solutions can be more expensive. There is also one more point on the server-based. We'll come to that. Uh, NVR can be cheaper for smaller projects. Okay. Now this is the server cost. Okay. What about licenses? NVR, there is no licenses required. In servers, they will charge per camera license. Okay. So let's say you're buying a VMS from, you're buying your own server, right? HP or Dell, and you will install VMS software. So the software company will ask you, okay, every camera, I will charge you a camera license to manage it. All right. So here, when you add the camera license for 200 into whatever price, then you will see that price of Windows base will slightly go higher compared to an NVR. And NVR is for a 64 channel. There are different options. If you go with the most expensive with the power supply redundancy, it will be around this price. If you go lower, maybe $2,000, you'll probably get much more cheaper solution. Okay. Now, your takeaway here is if your project has a smaller number of cameras, it is best to use NVR. If your project can afford a slightly higher budget, if your project requires to have flexibility in this future for additional storage or expanding the cameras, go with the Windows based, because you can always change the software inside. You can always add additional spec inside and make it comply to the new VMS, or add more cameras to the existing VMS that is in the Windows recording servers. Okay. Now, Windows based recording servers, there is two options: from vendor, from third party. From vendor means products like PRP 5000, Wisenet, then Milestone Husky. So these are uh, vendors providing very expert. Okay, I just, so you will see recording servers, although they are with Windows, but the vendor itself can provide, servers. Vendor itself will provide servers like this. Okay, built-in recording servers, pre-installed Windows, pre-installed video management system. So this is our recording server with Windows, by the way, and they will do this effort for you. You don't have to buy, you don't have to check which CPU to use and all that stuff. They themselves will take the headache. But what benefit do you get in this case? First benefit is you still get the flexibility option. You are buying from a vendor, but it's flexible. You can, it's still Windows, right? You can format, put some spec, whatever. You can add, remove programs. You can change what you like. You can upgrade the RAM. You can add some card. You have the flexibility to do what you want. Third party, of course, you will be buying from other Dell or HP or IT supplier, right? Okay. Now, this, when you buy from vendor, one point of contact for you. Okay, so if you have any issues, you will just contact one vendor. You don't have to jump between multiple vendors. Okay, so that's why this is also becoming very popular among vendors. You don't want to take a quotation for camera separately, BMS software separately, HP server separately, and so on. They want to buy everything from one vendor, and support also will be from one vendor. And because the vendor is giving you, he can give you bulk discount and give you a good pricing. But if you buy three products from three different vendors, you may not have a bulk discount because your the quantity of products is less in the BOQ for each vendor, right? So that is one. But still, there are people who prefer to buy from third party. For example, large IT, large corporates, they have a direct agreement with Dell on yearly or every 3 years. They will replace the hardware. They will have enough spare hardware for these purposes. In that case, you can go with this setup. Okay. Then vendor hardware, vendor hardware still has limitations. Okay, if you go with uh, our server, Windows so and so, okay, Xeon processor. If you take this guy, it will have certain processor. If you take this guy, it will have some processor. Okay, maybe you don't like it. You don't like this Xeon processor. You want something else. You want dual core. You want four core. You want to do virtual machine. You want to do all this. Then you cannot ask the vendor to do it. They will not have that option. They will just have a basic, most commonly used, okay, 300 camera server, 200 camera server. They will not have much higher than that, or they will not give you that more flexibility that you require. Then in that case, you may have to make your own, by your own. Okay, all right. And also another key point is SAN storage, dash storage. I will come to that. That time you will get much more clarity. Okay, what is the summary here? Both are good. Both have their own benefits. Linux for sure is very stable. I have also uh, as long, I mean, it's just keeps working, and if you don't disturb it and simply unnecessarily change some hardware or anything, it just works fine for years and years and years. So that is a good thing about Linux. Windows, yeah, it requires some kind of intervention once in a while, and it is dedicated for CCTV only. So this hardware is designed for CCTV. You cannot reuse for some other purpose. Windows, of course, you can choose what processor, choose the RAM, choose the server operating system. You can choose what you like. Um, New features, new enhancements for VMSs that are on Windows, they are much more faster. You will get yearly two updates. In a Linux space, maybe probably you'll get once a year or every 2 years. It's much more slower. Then they are pre-licensed. There is no licenses when you use Linux space. It's all pre-licensed. Whereas in Windows, even the Windows operating system is a license. Every camera they will charge a license. Okay. Now, uh, in this Windows based, there is one more point. Yeah, there is a question. It's a good point. There are two options, right? Yeah. You can buy from vendor or from third party. If you buy from vendor, vendor will pre-license it for 100 or 200 or 300 cameras. So you still will get a benefit here because it is pre-licensed. There is a license, but they will pre-install it. So you don't have to go and buy separately additional license. For example, here, this particular PRP 5000 is for 128 channel. Let me see, 128. Yeah, 128 channel. It's already pre-licensed. Although it is Windows, because you're buying it from a vendor, they will pre-install everything on the Windows machine and license it already and give it to you. Okay, I believe it will be the same also for these guys, or you may have to activate it. But license you will not be paying separately, but it will be included in the hardware price. They will give you a key and you will activate it. Okay, but overall speaking, The process is when you buy directly from the vendor, they are eliminating as much of headache from you as possible on this licensing and choosing the installation software, all that stuff. It's already pre-done. Okay. From third party, definitely no, you have to license it separately. Next is storage. DAS, NAS, SAN. Very simple. If you see any hardware with a built-in storage, a built-in hard disk inside, NVR also, even here you can see built-in hard disk slots. Okay, you can see hard disk slots. This is DAS, directly attached to the recording server is DAS. NAS means over the network. Okay, server streaming the recording data over the network and dumping on the network storage. SAN is, let's say, let's see the benefit. DAS is much more faster, right? You know, DAS directly attached. For example, if you do file transfer in your laptop, it's very fast. But if you plug a USB or external storage, then you know it is a bit slow. The transfer is slower. So that is equal to like NAS. But if you want the same capacity, transfer speed, and performance of DAS, but if you look at the servers, it has only 16 slot. What if you need 20 slots? What if you need 50 hard disks? It doesn't have that option, right? And you cannot, let's say, how do you expand it? What you can do is you can buy a storage system called SAN, storage area network. They use fiber cable for fast speed transfer, and they will be on the network, but it will act as if it is locally attached. What do you mean by this? When I go to my computer, when you go to my computer, you see C drive, right? When you attach a SAN drive, it will look like D drive. It will be like E drive, F drive, as if it's locally attached. It gives you that same speed and performance, but it's on the network. Okay, that kind of net storage system is called SAN, whereas NAS will be like a network location. The file format is different. It's some of you already know when you have a NAS storage for downloading one file takes very long time, but it has its own purpose. If you have the right connection, you can still use NAS, but it's not as fast as your SAN system. For small projects, standard projects, people use NAS. I'm not against it. Each have their own benefit. SAN also can be very expensive, by the way. Having a fiber switch itself is expensive, so SAN storage would be, of course, much more expensive. Okay, so if you're talking about, there are some questions about Hanwa. If you buy our server, Hanwa server, recording server, Windows based, there is no license. We don't have any recurring license, no yearly license of that sort. It's just one. It's all preloaded. It's lifetime. If you don't want our server, you can also buy from HP or Dell. If you buy from HP or Dell, then we will charge camera license. Again, that is lifetime license. Some vendors have a recurring license because they are a software company, right? That's how they operate. We are a manufacturer of and also developer, so we are all in all. We have a big product profile, so that is our differentiation. But some vendors are only software. That's how they survive. So they have their yearly licenses. Of course, there is more benefits also. They will give you a lot of integration options. You may not need, maybe you need only 1%, which we can also provide, but they will give you 99 options. And so you have more flexibility of integrations because it's a software company. They will have nine, majority of the staff are just developers. So that way it is good, but it's also expensive. So most of the CCTV systems, they need CCTV access control. For that, you can go with a single vendor solution also. Okay, so if you have any questions up to this point, feel free to let me know. And let's go further. A little bit on, yeah, okay, question. DAS is available, yeah. Every NVR with built-in hard disk is DAS. Your laptop with the storage is a DAS if you're recording on it. Direct attached storage, yeah. Anything separate, yeah, NAS SAN is bought separately. Yeah, that's a good way to put it. Okay, so trace okay, this is a very simple tool. What is a tool that we use to find when the camera is online, offline? We used a tool called command line called ping, right? Ping means you directly ping a camera and it will check whether the camera is offline or online. But what step did it take? How many switches did it cross to ping? So that is called trace. So trace cert. When you put trace at google.com, first you will find out that my PC is trying to communicate with the gateway. My gateway is 50.1, so it is going outside my network because I am trying to contact google.com. So it is reaching the gateway. After that it is going to Etisalat using my IP, reaching their router. From there it is going on checking where is the final server, where is the final location of Google server. Okay, so basically it reveals the router address. My router address is 50.1, so it reveals where the router is, and you will be able to figure out uh, how I mean, the destination, you're the source and google.com is the destination. In between, what all route it is taking in the networking world, right? How many switches it is crossing, how many places it is reaching to finally reach Google. So first it will go to Etisalat, from Etisalat to their DNS server, from their DNS server to local, maybe local data center somewhere here. From there it is going to connect to the Google. If there is a Google server here, from there it will reach Google. So it will show you the path taken to reach the destination. That is tracert application. You don't have to remember all this, but at least for now, if you know, okay, there is a difference between ping, there's a difference between ipconfig, there is a function to trace the path that is called tracer. You can always look it up in Google later. Then Wireshark. You hear about this word Wireshark all the time. Now, when you know there is a communication happening between a server and a camera to access control system, you know all the functionality is going on, everything is fine. But for some reason, the integration is not working. Access control and CCTV integration stopped. Or maybe the camera was connected to some FTP server and it stopped working. Or some access control integration stopped working, right? Uh, but connection is fine. So how do you figure out what's going on? In this case, you need to know what the access control is actually sending to CCTV, whether it is sending it to the correct location in CCTV, in the correct format, in the correct command line. If you want to know exactly what packets they are sending, then you need Wireshark. If you want to know whether it is sending or not, you don't need to worry about it. You just do paying and other things, that's fine. But if you want to know what is being sent, whether it is correct, whether the packet type is correct, because maybe CCTV is saying send me only packet size less than 1 MB, send me in this format. You should put first line should be this, second line should be this. So if the access control is not sending in the correct format, you can check using Wireshark. You can check the packets whether it is being sent correctly, whether the command line is being sent correctly. So that is the purpose of Wireshark. Okay, you can filter it's called sniffing of packets, and you can use many filters to figure out, see, source to destination. Show me all the packet between the source IP to destination IP. And from that, if you want to know specifically certain command lines, you type it, it will show it will filter by those command or this protocol, or it will filter by whatever keyword you type. It will show all the traffic. Okay, maybe you're looking for a specific command line that a CCTV system should receive. So it's not, if it is not sending, you don't find it, that means access control is not able to send it in the correct format. So you can go and troubleshoot. You can figure out, okay, there is a bug in the software. So that's how they do this next level of troubleshooting. Okay. Then uh, what else? Yeah, OSI layer. Again, this one we will directly go to the summary. There is definitely a lot of resource online. Every networking system follows a simple. You can break it down into different layers. The physical layer is your cables, network ports. All this is your physical layer. Patch panels. Your on the floor you have this network ports, right? You plug this. That is all physical ports. That is your physical layer one. In the OSI layer, open systems interconnect. Basically, your networking system has to follow this rule. Okay, it has 7 steps. It has to follow each, and then before it reaches the final destination. Physical layer is your cabling. Application layer is your webinar application that you're seeing my video, you're seeing my PowerPoint, you're viewing this through GoToWebinar application. If you're using web browser, it is a Chrome web browser, right? If you're using Teams, that is Teams application. That is your final application. At the other side is the your laptop connected physically through this network card and the cable. That is your physical layer. In between, a lot of things happen that we will see. Okay. So next is this physical layer camera. If you have long distance and Cat 6 is not able to supply that distance, you will use media converter for 20 kilometer, 10 kilometer, and so on. Okay. Layer 2. Okay, layer 2. You would have seen when you go to the networking world, they will tell layer 2 switches, layer 3 switches. Layer 2 simply means it's a network switch which interconnects all the IP devices. If you have 5 laptops, they're all interconnected with the network switch. It will give an IP address to each of the laptop. Okay, done. But when you want to speak to um, another network, so you have your network here and you want to speak to another network, you need a router. This router is called a layer 3 device because it is interconnecting two switches. Okay, that is a layer 3 device which supports routing function. That is called a layer 3. There are switches which does both inter I mean you will find switches which can connect laptops as well as do routing in the same device. Okay, that also is available. Layer 2 and layer 3 network switches. It can do routing as well as switching. Okay, right now you have two switches and they're interconnected with another device called router. That is your layer 3 device. Okay, routers. So why do you need router? If you want to communicate with your finance department, which is on a different network, how will you communicate? Okay, so you will try to contact them. It will go through the router and then the router will reach that switch and then speak to the guy, receive it back, send it to you. So it interconnects two different networks. Router is also responsible for speaking to the internet. Okay, it connects your local network to the internet. Then we saw virtual LAN. In the same switch you can split the traffic. These 5 guys, you can say 2 guys are separate network and 3 guys are separate. You can do separation, but virtually. It is done using the software in the network switch, which all ports is belong to one network, the other belong to other network. Okay. Then um, layer 3, we saw this. Layer 3 basically does routing, interconnecting multiple networks. Okay, summary. Layer 1 is a physical layer. Layer 2 is switching. Layer 3 is routing. Layer 4 is your TCP UDP. Okay, once the routing is done, then it is now outside your network, right? Once it is outside your network, you have to follow the rules and regulations, right? When you go to some other country, you have to follow their rules and regulations. So there is this international standard for sending traffic network data, that is the TCP IP standard. So all the data will be converted to the international standard TCP/IP, and there is UDP. Basically, these are protocols. All the data will be sent in these protocols. Okay, till in your location you can do whatever you want, but once it goes outside, it follows the international standard. So it will intercommunicate with switches that is not in your facility. Maybe there are switches when you go to the internet. Of course, Google will use some brand of switch, right? You don't know what switch they're using. So you need to have a common language, right? Just like on WIF, you have this common language called TCP/IP standard. Then all the data will be sent in that standard. So the Google switch will say, yeah, I can understand what you're asking. You want to know, you want to search something. It will search and send the result in TCP/IP. It will come back to you, and your switch can read it because that also follows TCP/IP, and then it will decode it back to you um, in your application layer, so you can see it on the web page. Okay, so that's the basic idea. All right, now VMS. I think it's time for a break. Let's take a 12-minute break, and then we will start on the VMS topic. Okay, let's resume our session. Okay, so I have some questions about RAID. I'm just going to cover that shortly, and also I will use our product as an example for your better understanding. Okay. All right, so let's look at a typical video management system. A video management system will start, of course, with cameras. The cameras will be connected to network switch. The network switches are connected, interconnected. Yeah. So there is a delay in my system. Okay, the switches are interconnected. Each switch is on different location. So you have a control room where all the recording servers are connected. You have the video wall servers are connected. Then we have another place where the operator PCs are connected to switches. So they're all interconnected. The video management software will be installed on the recording part. The video management software will have multiple, you can say, sub software, the client application, the recording application. So the recording application will be installed here. Then video wall application will be installed on the video wall side. The client application will be installed on the operator side. Okay. Then let's say integration. If the video walls, if the CCTV system is integrated to access control, you will have in the CCTV software, you will have a pop-up functionality available. Whenever there is a card denied access, you will get a pop-up with the card holder name and the card holder image. Who's giving this information? Access control. Okay. And where are you viewing this? In CCTV system. In the CCTV system, you can view an incident. So let me show you by marking. This part is the live video from the camera. Someone tried to access, he didn't get access. And this part is the person who tried to access, what is his information. So you can check, okay, this person swiped the card, whether it was really the same guy who swiped. Okay, you can check that. You can also unlock the door from the CCTV system. Maybe his card is expired, but he's not able to access. You can open the door for him. You can have one map with the CCTV icon as well as access control icon. So this is the benefit, single interface for operators. Operators. Management you can have separate, maybe access control some other brand, CCTV some other brand, it's okay. But for the day-to-day operator, he will have a single interface for both the systems, unified platform. Now, then we'll talk about RAID. RAID and storage. Okay, RAID simply the full form is redundant array of independent disk. Okay, so the it can be divided into two parts. Independent disk. Independent disk is means no RAID. Okay, but if you are going to make it as a group, okay, and that is called array. If you're going to make it as an array, they belong to one group, and you want to give redundancy or redundant array of independent disk. Okay, you're going to make that group of hard disk redundant. What is a redundant? Redundant means you have two hands, right? That is redundant. Two legs, redundant. You can somehow manage to take something, can somehow manage to walk or move. That is redundant. Same way in CCTV, um, there are two network ports. One port fails, you can still access the via other port. You have two power supply. One power supply fails, you can still power the NVR or recording server with the other power supply. That is redundant. Same way in hard disk, if one hard disk fails, still you can continue recording, still you can continue playback. That is redundancy in the NVR. What is failover? Failover means if both your power supply failed, you need to replace it. Okay, you need to replace the NVR or you need to replace the power supply. The complete unit has failed simply. Okay, if both the power supply failed, recording stopped, live view stopped, playback stopped. Okay, then till you replace, it is stopped, right? Can you replace within 1 or 2 seconds? No, you will need some time. You will need to probably check where the power supply is and do some maintenance, ask some people to come and replace. So during that downtime, you need a standby unit to start recording. That is called failover. When there is a downtime completely failed, in that intermediate till the system is coming back online, you have to have failover. You need to have someone else do the job. So when you go on leave, someone else is doing the job intermediately, not permanently. Once you're back, he will transfer everything back to you, right? So in CCTV, same thing. You will have a standby NVR, standby server, and it will be recording till the actual server comes online. That is failover. Okay, you can have failover n plus 1. That means there will be one standby NVR to handle 5 or 10 NVRs or recorders. Okay, let me write this. N plus 1 failover simply means there is one failover for n recorders. N can be 10 or 8 or 5 or 6. It can be any number. It can also be 100, but that is not a practical scenario. Yeah, 100, 1 is to 100 is not practical scenario. 1 is to 50 is not practical scenario. So 1 is to 10 is good. 1 is to 4 is good. 1 is to 6 is good. All this is good scenario. But having 1 is to 500, 1 is to 200, that is not practical. Okay, you can do it, but there's no point of having failover there because at the same time, 2 or 3 can fail, right? And one standby cannot handle all the load. Okay, so that is failover. Redundancy means within the system, right? Within the system. So if a HDMI port failed, you will have VGA. So you can, if there are two HDMI port, one port failed, you will still use the other port. So that is redundancy. Same way in the hard disk, there is a group of hard disks. So HDD1, so in your NBR, you have an array of 8 hard disk. If any one hard disk fail, you should continue recording. Okay, that is right. So how does it continue recording? You will make it as a group. We call it array. Within the array, you will set up a RAID system. So they will become as one big hard disk actually. All right. Then they will work together and they will write. So let's see what is RAID 5. There are different RAID systems. Okay, we'll start with the RAID 1, RAID 5 and RAID 6, commonly used in CCTV. If you set up an in this array RAID 1, that means this you will set up these three hard disks will be recording. Okay, and 456 will also be recording parallelly. Okay, I think we'll take a simple example. RAID 1, HDD1. For every hard disk 1, you need another hard disk 2. So if you're recording in 1, it will record parallelly in 2. Okay, so here you go. RAID 1. Two hard disks make a single array. Okay, half the number of hard disk is used for redundancy, which means if you have total of 4 terabyte, let me remove all the marking. If you have total of 4 terabyte, only 2 terabyte you can use. The remaining 2 terabyte will be used for RAID. It will be parallelly recording. Okay, it will be copying your data. So if one 2 terabyte fail, the other 2 terabyte will have a copy of the data. So at any point you have no loss. Okay, so in order to do RAID 1, minimum you need 2 hard disk. Okay, because you need to copy. Okay, and if you have 2 hard disk and each you are inserting 2 terabyte, your total storage is not actually 4. You can only use half of it because you enabled RAID 1. So one, it will write 1 here, another hard disk, again it will write 1. So same copy will be there in both the hard disk. So your actual usable storage is only half the total capacity. Okay, that's why we use words called raw storage and usable storage. Raw, RAW, raw storage and usable storage. Raw means total 2 hard disk, total 4 terabyte raw storage, but usable after RAID 1 is 50%, only 2 terabyte. That is called usable storage. Okay, now it's you see here usage efficiency 50%. RAID 5, you need minimum 3 hard disk because RAID 1 is not is good, but it's expensive because if you need 200 terabyte to record, you need another 200 terabyte for RAID 1. So you have to buy double the storage. Your end user will say, I don't have money for this, it's too expensive. So then you will come give a solution called RAID 5. RAID 5 means you will have 3 hard disk, okay, minimum 3. uh, so when it records, it will record some part in hard disk 1, some part in hard disk 2, some in hard disk 3, some, and in the fourth hard disk it will not write the useful data, it will write a backup data called parity bit. Okay, parity. Same way, next it will record the next data in 3 parts, B1, B2, and it will record a parity bit, and then it will record 3. How to understand this parity concept? Okay, this is the example I use. I got this from a previous company colleague. This is how he taught me. So when you, let's say there are hard disk 1, hard disk 2, and there are 3 hard disks. Okay, this is A1, A parity, and A3. So this is that extra bit of data that the hard disk will write in case there is a loss. Okay, so let's say hard disk 3 failed. Hard disk 3 is dead and the value is 2. Okay, the parity is 1. That means, okay, according to this hard disk, 1 plus 1 is actually 2. So if 2 hard disk 2, I mean this third hard disk is gone, the value is x. Okay, it knows that, okay, x is equal to a1 plus a parity, that is a value, that is 2. 1 plus 1 equal to 2. Okay, what if hard disk 2 failed? Okay, what if hard disk 2 failed? So you have value 1, you have 2, and this hard disk is gone. So according to the software, how it will check? It will check, okay, I have A3 minus A2 will give me AP. So that is 2 minus 1, this value minus this will give me 1. So I will find the value of AP is equal to 1. All right. So basically it is writing in zeros and ones. This is just a representation. So every time it writes a value, it will keep a backup data. So in case anything is lost, it will do the calculation and recover that value. Because it's ones and zero, it can write like this. Minimum you need um, so one parity bit. Minimum you need one parity bit. Okay, so you can see the text here. Uh, some parts of the each HDD is used for redundancy. That's every hard disk, some part will be used. The total part is roughly equal to one size of one hard disk. So if you are buying 4 hard disk, one of the hard disk size will be fully used for parity data. Okay. If you buy 3 hard disk, one of the if you buy, let's say, let me write it down again. HDD1 1 tera, or let's say 2 terabyte, HDD2 2 terabyte, HDD3 2 terabyte. So your raw storage is equal to 2 plus 2 plus 2, that is equal to 6 terabyte. But according to RAID 5, one hard disk size will be used. From each, some of the storage will be eaten up by RAID parity. The total parity storage will be equal to size of HDD, one HDD in the array. Okay, so that is 2 terabyte. If you take any one hard disk is equal to 2 terabytes, so that is gone. So raw is equal to 6, usable will be 4 TB. Okay, why only one size? Because according to RAID 5, you can you can lose one hard disk and still recover it completely. So you can see the text here. You can resuscitate only one hard disk from error situation, which means if hard disk 3 failed, no problem, buy a brand new hard disk, put a brand new HDD. You bought HDD4 here and you replaced it. You put a brand new 2 terabyte, no problem. It will recover the lost data as if nothing happened. Okay, by doing all the formula of parity bits, it will restore the lost hard disk. Your HDD3 is dead, but you replace with a brand new HDD, no problem. It will completely recover the data. Okay, this is RAID 5. Up to one hard disk, you can lose and recover it. If you lose one more, your RAID 5 will collapse. You will lose everything. Okay, everything A to Z, all the data is lost. What is RAID 6? RAID 6, it has two parity bits. So up to 2 HDD can be recovered. So you need minimum 4 hard disk here, minimum 4 hard disk. Okay, so if you see the PowerPoint, it will write 2 parity bits. AP parity bit, again it will write one more parity bit. Here it will write 1 parity, 2 parity. So you can recover up to 2 hard disks from the situation. Also the thing is, you will 2 hard disk data will be used. If you use 4 hard disk, 2 hard disks will be gone. Okay, so 2 times parity is written, so half the storage is used, but not always half. If you have hard disk 1 and HDD, okay, if I have, let's say, 10 hard disk, okay, each 2 terabyte. So from here, total storage is equal to 2 into 10, 20 terabyte. Parity is size of 2 hard disk. Parity is the size of 2 hard disks. So 2 into 2, 4 terabyte is gone. So your usable will be 20 minus 4, 16 terabyte. You can use remaining 4, you have to leave it for the parity bits. Okay, so if you use only 4 hard disk, you need minimum 4 for RAID 6, 50% is gone. But if you use more in the array, so you can see it will be 16 by 20, around 20% is gone. Okay, so that's how you calculate. Right. Every vendor, they have their own calculator. You have to use the calculator of the storage device. If you buy storage from Hanwha, you use the calculator of Hanwha, because we do RAID for every 8 In some NVR we do every 6, some we do every 10 or 12. You can customize in some recorders also. Some vendors will do every 4, they will use RAID 6. Some vendor will use every 20 RAID 6. So you have to calculate the rate based on that vendor storage system. But you can always do a thumb rule. Of course, you can take thumb rule, 25% storage is gone for RAID, but there is a need to use that particular vendor's tool. What is the benefit of RAID 6? You can lose up to 2 hard disks and you can still recover it. Okay. Now this recovery is not immediate, right? If you're it is doing ones and zero calculation, right? So it requires time to do the calculation and recover the data. If you're having only 1 TB loss, 1 TB drive, it will it will do it quickly, and it is automatic, by the way. All of this is automatic. There is a separate controller called RAID controller in the storage that is doing this job. Your CPU is not doing it. Separate RAID controller is actually doing this work. Okay, some part of CPU is used, but there is a RAID controller doing this work. Okay, if each hard disk is 1 TB, it will recover quickly, and also depends on the RAID controller speed. So most of them are good, but if you have 10 TB, 16 TB, it will take actually very long time to recover that data, right? 16 times more time is required. That's what I'm saying. Okay, so you still have to keep in mind it will not be immediately recovered. Within that particular day, somehow it will recover roughly. Okay, now how to calculate storage? Okay, storage. And one more thing about RAID, every hard disk should be same size. If you use in the array one hard disk 500 GB, then it will consider all the hard disk as 500 GB. It doesn't matter if you put one 5 TB, one 2 TB, one 6 TB, doesn't matter. All the hard disk should be same in RAID 5. If you don't want to do this, don't use RAID. Use without RAID, it will consider as it is. But when you consider RAID, it will automatically calculate all the hard disks as equal. Okay, if one of them is low speed, low storage, everything will be cut and it will only use up to that. Okay, so it's like riding a chariot. If one of the, and there are 5 horses, if one of the horse is weak, everybody is weak. Okay, that's how it is. That is RAID system. So it's called a dead space. It will not be using it because you accidentally put 500 GB. Everything will be calculated as 500 GB. Okay, now how to calculate storage? There is we have two. I will show you two tools. One, the third-party tool, JVSG, and another one is Hanwa Security. Both the tools I will show you. You can go to our website. Parallelly, you can go to JVSG website. Okay, on our website, you go to Toolbox. On the toolbox, check what camera you're going to record. So go to network camera, not all, not this, not this, not this, not this. Go to network camera. I will zoom in a bit. Click on filter and select any resolution. You're going to record 5 mega. Okay, select 5 mega and select any dome, bullet box, no problem. Except PTZ. Don't select PTZ. PTZ will take more storage because it's always moving camera. Take any box or dome. Any box or dome. Okay, any box. Select any. Click calculate. Enter the number of camera. Let's say you have 10 cameras. You're recording 31 days, 5 megapixel. Okay, your storage is 12 TB, but you can click settings and record in H265. Okay, and you can record at 15 frames. You can check the recording schedule. It is recording motion for 6 hours and remaining continuous. Click the setup, make it all continuous. If you want to do motion 24 hours, change the time 24 hours, and 20% of the time there is people, it will do motion. Or if you want to do 50-50, you can also do that. 12 hours motion, 12 hours recording continuously, you can do that. Okay, so I'm going to do all continuous. Just change this continuous, done. Continuously recording 5 megapixel in H265 15 frames. and the storage is 11 terabyte. The first two you can leave it as it is, you don't have to change. White stream, if you want, you can make medium for an average project. Okay, so this is done. How to do third party tool? If you go to third party tool, you have your bandwidth at storage calculator. Select resolution, 5 mega. So where is 5? 5 MP, 16:9. Okay, H265, good quality, frame rate 15 frames, number of days 30, number of camera 10. What is the storage? Roughly 8 terabyte. Okay, so this is the storage for 30 or 31 days. So you can use any one calculator to do your storage calculation. Okay, both are fine, both are okay. It will be roughly the same. Okay, and that is more than enough. Practically speaking, cameras take much lower than what is actually shown here. Not much lower. Okay, so it will be within that budget, so you don't have to worry about it. Okay, this is your ballpark figure. So your storage is, just round it up, 9 terabytes you require for storing 5 megapixel, 2 megapixel or 5 megapixel. Why can't I select 5? Okay, 5 megapixel. I will require 10 camera H265. Where is H265? Yeah, I think the free version is not allowing this. 15 terabyte. According to this, 15 terabyte you require. As per SIRA regulation, I need 15 frames. What do you mean? Yeah, this requirement is H265 you can use because if the camera supports, you can use, that's fine. Most of the camera today support. This resolution and frame rate as per your requirement, as per regulation. Some regulation 12 frame, some regulation 10 frame, some regulation you can put 5 megapixel camera, but according to regulation you can only record 1 mega. So some regulation you have to record for only 30 days, some regulation 180 days. So based on the regulation, you can do this calculation. If you want to be vendor neutral, you don't know which brand you're using, you can use this calculator. It will give you roughly on a higher side. Okay, it will be on the higher side. But if you use specific vendor calculator that is specific to the camera, it will be more accurate. Okay, so if you want to do a general calculation, this guy is giving me roughly 30-40% more. Okay, for a for a project which you're not sure, this is more than enough. You get a ballpark figure. It should be around this figure or below. It's okay. Okay, but anyway, should be the ballpark figure storage. Okay, you can use this. Next is let's see how to do control room. All right. Today in CCTV world, there are too many cameras in the projects. There are 20, 200, 500, 200, 600, 800. These are normal nowadays. And the control room also has too many monitors nowadays. So how to design the control room? Okay. So for this, we can follow some guidelines. Let me, where is that sheet? Yeah. Yeah. So this is an Excel sheet based on the Excel sheet. Let me open that Excel sheet. How to decide number of monitors for your project. Okay, now if you have 500 cameras and the cameras that are critical, you have to divide it into two um, two types of view: critical view and normal standard view. Okay, critical view, or you can say less critical. If you use the word less critical, that may not be acceptable with many customers. So just standard, okay, standard cameras. Critical, if you have 500 cameras in the project, all the identification cameras, all the cameras in related to money, where money transaction is happening, all the sensitive areas, they are all critical cameras. Okay, they are all critical cameras. So you can do this calculation. All the identification is the ground floor camera, wherever money is involved, also somewhere in the ground floor, storage rooms, safe areas, finance department. So all these are critical cameras. So roughly 10%, 15% of the project is critical, right? So that you mark, remaining as non-critical. Then what you do, the critical cameras, you try to show it in front of the operator continuously. So when you go to the monitor layout, where is the operator? Yeah, in front of him, you should show all these critical cameras continuously. Okay, the rest you can put it in front of a video wall. You can put a video wall, and you can show all the rest of the cameras here, and you can do a feature called sequencing. What is sequencing? So if I have here multi layout cameras, every, okay, let me, okay, so I'm doing a sequence of two sets of layouts. Each layout has maybe a certain set of cameras. So in the same monitor, within 10 seconds, it will switch. So just watch here. I created a sequence. Okay, sequence, play. So this particular one monitor only, every 10 seconds it will switch. First it will show four camera, then it will show another four camera, then it will show another four camera. I'm not changing the monitor. The same monitor I'm reusing for more cameras. This is called sequencing. Okay. So the critical cameras you will not sequence, the less critical cameras you will sequence. Okay. Sequencing, touring, some vendor call it touring. Okay, so the critical cameras you will show continuously in front of the operator, and you can show in 5 by 5 view, 4 by 4 view. You can choose what you want. So if you use 5 by 5, up to 25 cameras you can show. So 25 cameras, and you need, if you have 75 cameras that are critical, so you need three monitors fixed in front of the operator. The remaining 400 cameras, 425, you will show in 5 by 5, but and at a time it will show 25 camera, but you every 10 seconds you will change, you will sequence. So within 1 minute, always keep 1 minute as your maximum. Within 1 minute I will change 6 times, so 150 cameras can be seen within 1 minute, because it is switching. What is switching? So if you see this video once again, it's showing this four cameras, it can be 25. After 10 seconds it will switch to some other batch. But I didn't change the monitor, the same monitor. So because I can see 150 cameras per monitor with the 6 sequences every minute, so I can easily cover 450 cameras. So I need another three monitors, 425 by 150. I need three. So total 6 monitors I need for this project. In addition to this, you can give one for supervisor for exporting video and other things. So sequence, fixed view, fixed view. Total 6 monitor. Okay, happy? So this is how you generally consider. If you don't have space, you can increase the layout size to reduce the number of monitors. But for the fixed view, not recommended to reduce too much, because it will become very small. Okay, so back to your setup. Uh, Control room design. Based on the number of cameras, you can design the control room. Now, there is some other general consideration, okay? All of this should be considered, but most of them are not considering this. Okay, by default, any operator cannot see the camera for a long time. Yeah, this Excel sheet will be sent to you. By default, any operator cannot look at the monitor. I'm sure most of you are not looking at the monitor right now, uh, because you cannot look at one screen for a long time, right? So you your attention span is not that great today, and it's reducing year on year. Okay, so you need to have, first of all, you need to hire a good operator who has got good experience. Second, the operator should have a sense of detecting abnormality. Okay, he should be quite simply, he should not be dumb. He should be sensitive to this environment. If he can see some guy walking in a very strange manner, he should be able to pick it up. Okay, he should be sensitive and alert. Okay, not only alert, that sense of recognition should be there. He should be good. Okay, for that, even for them, they cannot actually operate monitor continuously. Okay, so maximum 20 to 30 minutes with 5 minutes break, he is able to have give 100% performance. After that, it will drop substantially. Okay, now this is something global. Nothing can be done about it. Uh, People don't have the money to hire many operators for a project. So what you can do is you can focus on the critical cameras. Make sure it is in front of him and use analytics. Analytics will detect abnormality and alert the operator. Okay, it will help him to detect. That's the benefit of analytics. And the time required for the operator to detect is taken care by the camera, because the camera itself is detecting the analytics. So it will improve his efficiency. Okay. Then always try to keep in front of the operator similar scenes, all staircases together, all the entrances together, all corridors, keep it in that way, or first floor together, second floor together. So it's meaningful. Okay, the idea is meaningful and logical. Okay, so okay, there is a something called view in. Just because there is a monitor in the control room does not mean the operator can see it. If it is in front of him, that is his direct vision. If it is on the side, he's not going to see. If he has to turn his head to the monitor, that is not a critical view. Okay, that is, those monitors should be alarm monitors, alarm based monitors. The monitors right in front of him, okay, that should be critical. But if there are monitors on the side, you cannot expect the operator to turn and look all the time. So that will be, those monitors should have some level of notification. It should create a sound, it should create a pop-up and take the operator attention if there is any incident. Okay, then so we will see this. I have one slide. Yeah, so there is some guideline by a regulator body. So if you take CIRA guideline or Dubai Police guideline, they're saying each camera should not be less than so and so centimeter in the monitor. So what if you use a very large monitor? Can I put more cameras? Okay, so let me show you. So as per this criteria, actually CIRA also is not inventing themselves. They have taken this from best standards, global standards. So we can take it as an example. Okay, so if you have a monitor of 42 inch, 43 inch, Okay, the size and width is roughly generally so much. So if you divide that by the 12 centimeter guideline, you can go up to 7 by 7 layout. Okay, so this based on their calculations, I have made a table. So dimension, width, and height, you divide that, you can go up to so and so cameras. All right. Okay, there is also a question about full HD monitor or 4K monitor. Thing is, if you use 4K monitor, no problem, but it should be very big size. Secondly, if you use a full HD monitor, each pixel distance between the pixel will be um, less. But if you use 4K monitor, the distance will be small. So if you sit very far, you will not know that there are two different objects. It will be so close that you will not be able to detect any changes in the scene. So that's why when you use 4K monitors and too much of detail is cramped in the scene, you have to sit closer to the monitor. Okay, you have to sit closer to the monitor, the viewing distance. They call it the viewing distance. If you use a 4K monitor, your viewing distance is half roughly. Okay, you cannot sit far, you cannot make out the difference what's happening, so you need to sit very closely. So it is still recommended to use full HD monitor. If you use 4K, make sure you sit closer or you use bigger size monitors. Okay, so that's one reason why full HD is still popular. Even though they use 4K, they still use full HD for viewing. Okay, then to close for today, there are few small networking topics. Just for your reference, you probably know it, but just refresh this. Unicast, multicast. There are two types of CCTV systems in the market. Okay, and this is designed by the VMS. The VMS, how they work. Some CCTV systems are unicast systems, some are multicast. Okay, what is the meaning of the word unicast? Unicast means every time a recorder or an operator is asking for a video, you see here, let's say operator 1, operator 2, operator 3, or any time there is a demand for to view the camera, to view the camera, to record the camera, it will take the stream directly from the camera. Camera has to provide a unique stream for each. Okay, so that means camera is like a CPU, it is creating streams, right? So there will be a limit, 6 stream, 10 stream, 20 streams. Some vendor can do only one stream, some vendor can do only two streams. So that's their limitation. But yeah, so roughly that is unicast, okay? Directly taking from the source. Unicast is good because you are guaranteeing where the video is coming from, okay? But multicast means the camera will send only one stream, and if two operators are viewing the video, the switch will make a copy. Okay, the camera is not making a copy. Camera will send only one, but the switch will make a copy. You see, the switch has made two copies and will send it. This is multicast. So whenever so what VMS companies do, they will take the camera live view. They will take one stream from the camera, and you saw the recording servers, right? The recording servers will act like a multicaster. Okay, they will make copies and send it to multiple clients. You are viewing by mobile phone, you're viewing by multiple operators. That recording server can act like a multicast, or the switches can act like a multicast. So that depends on the VMS. So here your takeaway is you don't have to know how what each brand is doing right now. You just need to know the meaning. What is the difference between unicast and multicast, and where the multicast is happening? Okay, so sometimes some VMS companies they depend on the switch to do the multicast, not the server also. Some VMS companies they cannot depend on the switch because it's too much configuration headache. They themselves will act like a multicast server. So if you take a recording server from us, can multicast it. Milestone, from what I know before, they can multicast directly from the server, so you don't have to configure again in the switch. Okay, that's based on my previous experience. I don't really know what is their status right now, but for us, our server can do the multicasting. So you don't have to buy expensive switches, do multicast routing and other things. Okay, but there are brands today which purely depend on multicast, so they, because the camera cannot do it, so you will have to spend more IT configuration spend for them to configure the multicast side. So at the end of the day, you can buy a good camera or with more CPU to do more streams, or VMS companies which can do multicast themselves, or end up spending more for the IT people to do multicasting. If multicasting is mandatory, okay, no problem. But keep in mind, these are the two ways CCTV systems operate. Okay, and they can't really change. Any VMS company, they only operate in a certain fashion. Um, that is they call it their architecture. Very few can do both. Some can do a mix of both, multicast and unicast. So, but they will perform best in any one method only. Okay, and for again, one more takeaway for you is live view is all usually multicast view. Recording is always unicast because you don't want to depend on someone else to do to give you the recording stream. Okay, even if any VMS is doing multicast, they will do for recording stream. They will do unicast. They will take directly from the camera and record it on the recording server. Okay, they don't want to depend on the switch. They don't want to depend on some other server to send a copy. Okay, all recording should be done in unicast. So if multicast is happening by the server, camera will send. Okay, camera will still send in unicast, but the copying is done by the server. Let me show you here. Imagine this is server. Okay, not a switch. Let's say this is server, and these are clients, client PC. The camera will still send one data, one live view and one recording stream. The switch will make the copy and send all the live view copies here and there. If all three are recorders, it will send a copy of the recording stream to all three recording servers. Or this particular server will make the copy and send it. The server will still communicate by unicast to the camera, but from the server onwards, it will all be multicast. So if in your CCTV schematic, if you go back to the CCTV schematic, let me show you here. Schematic. Okay, so from the camera to the switch, to the switch, to the server is unicast. From the server to the live view is all multicast. Okay, so camera still has to send the video at least once. Okay, some vendors, they recording server will speak, the camera will also speak directly to the I mean the client will speak directly to the camera, the video wall will speak directly to the camera. At that time the camera cannot handle so much of direct communication, so then the camera will ask the switch, okay, I will send you once, you send it to the control, you send it to the operator, so the switch will do the multicast there if the server is not able to do multicast. Okay, in our system the camera will send to the recording. From here the live view is sent, recording is kept, live view is sent and multicasted. Okay, so both have their own benefits and negatives. So yeah, that depends on the operator. Many big VMS companies, they use the same concept, unique. They will do the multicast actually because they don't want to depend on the switches for the live view. So, but some VMSs still follow the multicast concept. Very rare, but there are. Okay, then port forwarding. Okay, port forwarding. The thing we coming close to our end of today's session. So we have port forwarding and then UPnP. Okay, just two to three small slides left. Okay, so port forwarding means your local LAN, right? You have an IP address 1.70, 1.50. All of you in your office, you have only one internet connection, right? But there are so many PCs. You're not buying so many internet connections. Okay, so who's doing that job? The router is managing your request and sending it back to you. Okay, and taking it from the internet and sending it back to you. Okay, now you have only one internet connection, right? Done. So imagine now, instead of laptops, imagine cameras. In your office, there are 30 cameras and you want to see over the internet. Okay, you have 30 IP address, but you have only one internet connection. Okay, so you have to do some kind of routing and forwarding. So when your internet connection will have only one IP address. Your IP provider will give you one IP address, but locally you have 30 cameras. Okay, instead of buying 30 internet connections, you will buy only one. So how do you address? So in the router, you will say, um, okay, if I connect to internet IP 10.10.1.5, let's say that is my internet IP, but I will give a traffic lane, a port number. So I will say port number 8080 means go to computer 1. Port number 8081 means go to computer 2. Port number 8083 means go to computer 3. You got it? So I will route from one IP, I will send to different port numbers for different cameras. So that is called port forwarding. Um, that is done on the router side. You will so whenever you type, whenever you try to access computer one, you will type 10.10.1.5 colon 8080. So it knows it should go to computer one. Okay, when you put 8081, it knows it should go to computer 2. Okay, it is done by the router side, and you configure this when you have CCTV. So simply put, if you want to access your cameras remotely, you do this mapping. You do this forwarding mapping. Okay, then let's say, okay, DDNS. What is DDNS? Okay, there are two types of IP addresses given by the internet provider: dynamic IP and fixed static IP for you. Okay, dynamic IP is what we buy for our home internet. Whatever internet IP is available free at that time, the Etisalat or Do or Orido or Reliance, they will give you this IP. After 30 days, your IP will change. After another 30 days, your IP will change. It will take it from a pool. Whichever IP is available, it will give you. Now imagine you're trying to access remotely. Every time the IP changes, then you cannot go and configure your router, right? Every time you have to update your router with the new IP. So that's a headache. Okay, that's why there is another service called DDNS service. This service will continuously monitor the IP of your home and it will update itself. Okay, it will keep updating the system that okay, whenever the IP changes, all the camera mapping, it will change automatically. Okay, that service is called DDNS service. And in this case, you will not, okay, that DDNS service, what it will do, instead of giving you IP address, it will say, it will give you a friendly name. It will say, instead of going to, see, instead of typing IP slash port number, you will type a friendly name, because the DDNS service provider will give you a friendly name. You'll say ddns.hanward.security.com slash your branch one. You will just type branch one. Automatically, that branch one will have the updated IP of your home and the updated port numbers. So it will manage this service for you. Okay, so that is DDNS. Okay, and P2P. To make this DDNS more simple, okay, DDNS still you have to do port forwarding and all that stuff. But although you use a third-party service, you still have to do this port forwarding concept in your router. Okay, so there is some amount of work required. You have to set up the DDNS, you have to set up the address and all that stuff. There is some amount of work involved. So today what they do is um, they install a P2P service application in the recorder. So you will just scan a QR code, automatically all the configuration is done, and it will connect through cloud a P2P service and send the video to you. Okay, so you don't have to do port forwarding, you don't have to do this configuration stuff. You just scan the QR code. Each device will have a unique ID, and via the internet, you can access your NVR from your mobile application. So let me see here, P2P, if I have a video. Okay, what's P2P? Yeah, so if you see here, you will download the mobile application. Okay, let's see. In your mobile application, there is an option called QR code or manual. Manual is your DDNS concept. QR code is very simple. Okay, then go to your device. It will have a QR code. Once you scan, so you will have something called, once you scan, you have something called unique ID. Okay, and you put the username password of the NVR. Through the cloud, you can access that particular unique ID, and that's it. So now when you go back to your I mean to the mobile application, you can see all the cameras. It's a 4-channel NVR. You can see all the cameras listed here. So it will load, take some time, and it will load. So all the camera, you can do live view, playback. You don't have to worry about IP address changing. You don't have to worry about port forwarding. Anyway, this is uh, this is much more also easier. Okay, so because each device has a unique ID wherever it is in the world, that P2P service will go and fetch it for you. Okay. All right. So that brings us to the end of today's class. Today, what we covered is basically what's VMS, what's a typical NVR, what is the purpose of it, and we saw storage types. Then we saw RAID. Then we talked about RAID 1, RAID 5, RAID 6. Then we saw control room. There was an Excel sheet. We showed how to calculate how many monitors are required. Then we talked about the analytics, how it helps get operator attention and how to place the monitors in front of the operator. Then we also saw about the port forwarding, DDNS concept, as well as P2P concept. Okay, so and then we saw layer 1, layer 2, layer 3, layer 4. Layer 1 physical layer, layer 2 switches for switching, and layer 3 is routing. Layer 4 is your TCP IP protocol. Then you have other layers that's not very important. Ideally, you need to know the last layer, that is the application layer. That's your interface, your operator interface. Okay, so that brings us to the end of today's session and also end of the course. If you have any further questions, I'll be online for a couple of minutes. And if not, please feel free to exit the session. Okay, and you'll receive the link for the quiz as usual.